Marie Curie, born as Maria Sklodowska, was born on November 7, 1867 in Warsaw, Poland. She was a physicist and chemist who advanced medical technology. When Marie was born, only 63 elements existed, and scientists thought they had found all of them.
She was the youngest of 5 children and was unable to go to school because her father couldn't afford it. University education was not available for women at this time. She got a job and raised enough money to get a train ticket to France. In 1891, she continued her studies at Sorbonne College.
When she first moved to Paris to continue her studies, she began by studying the magnetic properties of various steels. No woman had completed a scientific doctorate when she sought a thesis topic. Marie had a license in physics and mathematical science and graduated at the top of her class.
Mary met Pierre Curie, who was a professor in the School of Physics. In 1894, Mary and Pierre got married. In 1896, Henry Becquerel accidentally discovered a uranium compound which had the ability to fog up photographic plates. Mary was inspired by him to study rays emitted by uranium compounds for her doctoral thesis. Mary found that pitchblende, which is made of pure uranium ores and oxygen, was more radioactive than uranium.
She did tests in a shed that Pierre found and discovered that pitchblende was giving off stronger X-rays than uranium and oxygen made alone. To do tests, Marie put pitchblende in large pots and she stirred and cooked it and ground it into powder. Then she added chemicals to the substance to try to isolate the elements. Marie mixed the 2 substances with an iron rod almost the same size as her. After several months, they discovered polonium in 1898, which was named after her home country of Poland.
It was 400 times more radioactive than any other element. A few months later, the Curies discovered radium, and it took them 4 years to separate it from pitchblende. They named radium after the Latin word for ray. It was 900 times more radioactive than polonium, and it had a silvery green-blue glow. They later discovered that polonium was the product of the destruction of radium.
Since elements on the periodic table are arranged by weight, they concluded that polonium should be number 84 and radium should be 88. The Curies also made the terms radioactive and radioactivity. They used radioactivity to describe the behavior of uranium. It took Mary 3 years to isolate 0.1 grams of pure radium chloride.
They never isolated polonium because it has a half-lifespan of 138 days. This means that after 138 days, there is a half of the original amount that they began with. After another 138 days, there is a quarter of the polonium left. Pierre discovered that the radium emits heat, and its emissions damage living tissues. Now it is used for treatments for cancer and other illnesses.
This research led to the foundation of radiotherapy. They presented their findings to professors, and they claimed the rays emitted by radium and polonium were particles from tiny elements disintegrating inside elements. This went against the beliefs that atoms were solid and unchanging.
Their research showed that rays were released from the surface and within the atoms of the material. In June 1903, Marie Curie published her thesis, Research on Radioactive Substance. Examiners thought it contributed more to scientific knowledge than any previous thesis ever published. 6 months after the publication of her thesis, Henry Becquerel and both Mary and Pierre Curie got awarded the Nobel Prize in Physics for their joint research on the radiation phenomena discovered by Professor Henry Becquerel. In 1904, Marie Curie published a textbook describing the radium treatments for cancer.
Because of handling radioactive material, the Curies got severe burns on their hands and they got tired quickly. Due to their health, they were unable to travel to Stockholm for a lecture describing the importance of their work until 1905. After they were awarded the Nobel Prize, the Sorbonne gave Pierre a position as a professor and Marie a paid lab chief. In the spring of 1906, Marie and Pierre thought they were making progress on measuring radioactive gas emitted by radium.
But On April 19, 1906, Pierre Curie was killed in an accident when accidentally stepping in front of a horse-drawn wagon. Sorbonne did not offer Pierre's teaching job to Mary immediately, since they did not allow female professors. But after a month, Mary was offered Pierre's position because they knew she was the only one capable of filling his position. She accepted it, becoming the first female professor at Sorbonne College. Doing so, she hoped to establish a research institute in his honor.
Marie was absent from her lab for most of 1912 because of a scandal that was caused by rumors that she had a romantic attachment to a former pupil of Pierre named Paul Langevin. During the scandal, Marie received a notice announcing her award of the Nobel Prize in Chemistry, but a Swedish scientist encouraged her to decline it until the scandal ended.
This would make her the first person to be awarded 2 Nobel Prizes. Mary was making progress in establishing the Radium Institute, but World War I prevented it from opening in 1914. She served as the director of the Red Cross Radiology Service. Mary's goal was to be able to use X-rays in military hospitals. She and her daughter Irene used them to locate bullets, shrapnel, and other broken bones.
This saved many lives. If shrapnel, which are fragments from a bomb, shell, or other object thrown up by an explosion, are left in the body, it can lead to infection or damage of the organs. They weren't fully aware of being exposed to X-rays, so they wore cloth gloves and occasionally separated themselves from the equipment with small metal screens to avoid direct beams.
They equipped and staffed 200 radiology posts with both men and women. They used military radiotherapy services, which is ionizing radiation to destroy cancerous tumors in the body. To do this, radon was put into sealed glass tubes, which were inserted into a patient's body to destroy diseased tissue.
Marie invented radiology cars during World War I, in which they brought X-ray machines to hospitals for wounded soldiers. Over 1 million soldiers were X-rayed, and many lives were saved in the last 2 years of the war.
Mary dedicated most of the rest of her life to the Radium Institute. She isolated radium metal, published a textbook on radioactivity, and secured the right for defining Curie, which is the international standard for radium emission. This was used in industries and medicine.
Soon her health declined, and she died in a sanatorium on July 4, 1934, in Savoy, France. The sanatorium director believed it was from the amount of radiation, but when her remains were transferred to France's National Mausoleum in 1995, researchers found that the amounts of radium in her coffin were too low to cause death. The theory is she died from exposure to X-rays during the war or from a type of leukemia because of radioactivity.
Curie's oldest daughter, Irene, and her husband won a Nobel Prize for Chemistry in 1935. Their youngest daughter, Eve, is the author of a famous biography of her mother called Madame Curie.
Scientists eventually became aware of the dangers of being exposed to radiation. The energy of the rays speeds through the skin, slams into the molecules of the cells, and can harm or even destroy them. Exposure to radiation eventually leads to cancer, since it kills cells or damages DNA within them, which hinders the ability to reproduce.
Radium is used in small amounts to make X-ray pictures in medical fields. When people get X-rays, they must wear lead aprons to prevent germ cell mutations. These mutations can potentially be passed on to further generations.
Polonium occurs naturally in the Earth's crust. It's a product of radioactive decay of uranium-238. Then it decays to radon-222 and then to polonium. Pure polonium-210 must be handled carefully. If inhaled, it can be fatal. It is very rare to get a fatal dose of polonium, since it would take tens of thousands of sources to make a fatal dose.
Since polonium-210, which is the most common out of all of them, cannot penetrate skin, external exposure does not pose health risks. Because some types of polonium are fatal, people must be licensed to distribute it and work with it. In recent years, polonium has been used to poison people. After entering the body, it can destroy organs and immune systems.
For example, a man from Russia named Alexander Litvinenko was poisoned by polonium. He died weeks after drinking tea that was laced with a fatal amount of polonium. On November 1, 2006, he fell ill and was hospitalized. His symptoms were hair loss, nausea, and vomiting, lowered white blood cell count, and damage to bone marrow. Later that month, on November 23rd, Litvinenko died.
Marie Curie proved herself as a scientist in chemistry and physics when men dominated science.
Her discoveries led to advanced medical technology that saves many lives and is used all around the world today.